Good afternoon, colleagues. Alexander Vetoshkin. I want to introduce you a cases of surgical treatment of chronic instability of the shoulder joint recurrent dislocation with a large loss of bone tissue. In the plan of preoperative examination performed by spiral computed tomography of healthy and damaged joints. Using the data of computed tomography, perform 3D printing of the articular surface of the scapula and the humeral head. This allows to estimate the total volume of bone loss and deliver the statement to perform bone plastic surgery Latarjet. With a total defect of 1 cubic centimeter performed arthroscopic surgery Latarjet, developed by Laurent Lafosse. To measure this indicator fields in defects on printing model on the damaged joint is sculpted plasticine, comparing the correctness of circuits with undamaged joint. After that, the computed volume of plasticine using density and mass, or simple immersion in a chemical measuring utensils, measuring the volume of displaced fluid. Operation number 1. Arthroscopic Latarjet procedure. Set the arthroscope in the standard posterior port A and produce the estimate of the joint to final adoption of the surgical solution. Access the head of the humerus and visualize damaged Hill-Sachs, a performed dynamic test. In this case, the defect engaging on the concept of NG allow is a track of the damage. For positioning the front portal E, use a spinal needle and put the front port in the rotator interval over the tendon of subscapular muscle. Using ablator, execute the release to the glenoid lip and the anterior capsule of the joint and open the rotator interval. I usually use the electrode Johnson & Jones MyTech. It allows aggressive enough to remove the soft tissue, has good coagulation properties and doesn't lead to femoral injury of the shoulder joint. After the release of the lips, check the possibility presence of bone damage Bankart. Bone fragment removed. Open the rotator interval and anterior joint capsule between the upper part of the tendon of the subscapularis muscle and tendon of a long head of biceps. Exposing the lateral and lower surface of the coracoid bone allowed the tendon or the short head of the bicep and the coracoid muscle to remain attached to the coracoid process. In this case, the joint capsule in anterior thickened, a clear sign of hyocapsulitis. So, you can use the shaver to expedite its release. After visualization of the coracoid acromial ligament, it's cleaved. Use of the Coracoid process. Use a spinal needle as a marker. Enter it parallel to the tendon of the subscapular muscle and the blend tool port D. This port translates the arthroscopic use of the anterior articular process of the scapula in the area of damage. With the help of vapor, remove the remains of the middle and lower shoulder articular ligaments, the joint capsule, using the bone drill performed by the processing defect. We examine the Coracoid process through a port D. Port E performed by cutting off the tendon of the minor pectoral muscle. The working part of the electrode is positioned laterally to avoid damage to nerves. Before completing the split in the subscapularis muscle tendon between the joint tendon and the tendon of subscapular muscle, visualize musculocutaneous nerve to avoid its damage. Perform the processing of the lower surface of the Coracoid process using the bone drill. The main task is to perform decortication the lower surface of the Coracoid process for a good seam with the scapula. To perform the split in the subscapularis muscle, in the back port we input switch ports, which enter through the subscapularis muscle on the border of middle and lower third. In doing this, again visualize musculocutaneous nerve to avoid damaging it. Using the APR performed split in the subscapularis muscle, which should be wide enough. With the help of a spinal needle, position port H over the Coracoid process, into which you enter a special guide wire for positioning the spokes. Spokes position strictly on the middle line of the Coracoid process, in order to avoid further divide it along its axis. The spokes of a special 3-step drill to put a hole, which then passes with a tap washer under the top head. introduced into the Coracoid process of these washers. It's desirable to see a spoke so as not to lose washers in the joint. After this, they blend to port M, to which the input holder of the Coracoid process. Summon the holder of the Coracoid process to the washers and fix it using the long screws. Using a retractor which is inserted into the posterior port A, expanding split in the subscapularis muscle and hold it in the Coracoid process with the bracket. Position the Coracoid process on the front edge of the blade from 3 to 5 o'clock on the dial and fix it to spokes, which enter through the shoulder through to back surface on the body. At this stage, it's important to be under a maximum angle of 20 degrees to the playing glenoid. The exit point of the needle should not be removed more than 5 cm from the port A. On the spokes, alternately perform the remain blades drill at 3.2 mm using the marks on the drill is determined by the required length of the screws. Into the bottom holes injected cannulated screw using cannulated screwdriver. Upon reaching a small compression, change the screwdriver or not cannulated and perform final fixation of transplantate. Perform final inspection of positioning, reliability and accuracy of positioning of the graft. If necessary, you can use a bone drill for final modeling. After the operation, control performed X-rays for assessment of bone block. Passive movements in the joint are allowed from the first day after surgery. To active movements, it's recommended to begin after 4 weeks. After 3 months, there was spiral computed tomography, which assessed the adequacy of fusion of the bone block with a scapula and lead spot. Operation number 2. Arthroscopic Latarjet procedure and free alloplasty of the Hill-Sachs defect of the humeral head. The detection of the bone defect of the humeral head more than 2 cubic cm arthroscopic Latarjet procedure is supplemented by free bone alloplasty, using the technology of 3D printing for the manufacture of preoperative bone transplantation in individual plastic 3D model. In the resulting bone block of the overlay holes for the mounting screws. Preoperative manufacturing individual bone graft significantly reduced the duration of surgery plastic surgery defect Hill-Sachs. The graft is installed from a separate direct access. Given the prospect of a loss of density of a free bone block during the surgery defect Hill-Sachs, we have developed technical specification for fabrication of 3D element, the articular surface of the humeral head, allow remutation CL. Prepared technical documentation for 3D element based allow characteristic ISO and parameters products, polished articular surface, trabecular contact surface with holes for fasteners. Performed computer modeling of the product in accordance with the technical specifications. On a 3D printer Iosin M270 titanium alloy-made product for laser-facing articular surface of humeral head with a polished articular surface and trabecular contact surface. Product exactly corresponds to the real defect in the humeral head. I applied the 3D printing technology of manufacturing elements of laser-facing of the articular surface with significant bone loss, so we clinical results cannot imagine. Asking colleagues to comment on the presentation on the prospects of applying this technology. Write down your comments, colleagues, please.